Hello, welcome to the Keen Lab YouTube channel. This project is entitled Bioink Material Stiffness and Composition Promotes Chondrogenesis. The overall goal for this project was to use a biology-driven approach to select material combinations for 3D bioprinting cartilage. This is possible by using our novel chondrogenic assay that uses a secreted gauge-luciferase to measure type 2 collagen production. We investigated combinations of gelatin methacrylate, or GELMA, and hyaluronic acid methacrylate, or HAMA. We also used LAP as a photoinitiator to increase material stiffness. We measured this material stiffness using dynamic mechanical analysis. This first figure is a 3D surface model with % GELMA and % HAMA on the bottom left axis, and cross-linking time on the bottom right axis. Stiffness in kPa is going up the y-axis. We found as the % GELMA and cross-linking time increased, so did material stiffness. The next four figures are all showing data collected from a screening using the reporter cells previously mentioned. This first figure has two graphs. The top is GELMA alone, and the bottom is a 1-to-1 ratio of GELMA to HAMA. Both graphs show the type 2 collagen expression over the 22-day assay at the three different cross-linking times. These graphs show that type 2 collagen expression depends on both material combination and cross-linking time. Figure 5 shows the day 22 type 2 collagen expression of the 5 groups after 60-second cross-linking. This graph shows that combining GELMA and HAMA increases type 2 collagen expression as compared to each material alone. This also shows that having more GELMA in the ratio is better than having more HAMA for type 2 collagen expression. Figure 6 shows the same 5 groups after 60-second cross-linking, but this graph shows the type 2 collagen expression over the 22-day assay. Also on this graph is the cell aggregate control. This graph shows that the cells being in materials increase type 2 collagen expression as compared to the cell-only control over the 22 days. This final figure puts together both the stiffness on the x-axis and cumulative luminescence on the y-axis. As demonstrated by the trend line, we can see that above a stiffness threshold of about 30 kPa, there is a similar cumulative luminescence. In conclusion, we used our novel temporal chondrogenic assay to improve upon traditional methods to optimize material selection for 3D bioprinting. Chondrogenesis was improved by combining GELMA and HAMA, and this was dependent upon both stiffness and material ratio. I hope you enjoyed this brief overview of my project, and thank you for listening.